We are looking at cigarette consumption for America. And we have years starting in 1950 through 2010. And we are told to enter the data in our calculator. So before we get started, let's think about what we're going to be doing. It says to let X represent years since 1950. So this is year 0. From there, it goes to 1955. So it looks like it's going up by 5s. So my years are going to be 0, 5, 10, 15, etc. So I keep counting these up. And it looks like it will go up through year 60. So in my calculator, these numbers that are going by 5s are going to be my list 1, and then the actual data is going to be my list 2, these numbers. So I did work ahead, and so in stat, I have already entered this data. So the next thing I want to do is I want to take a look at the plot. So I'm going to go into my y equals, clear out what I had from before. I'm going to arrow up and turn plot 1 on. Now I'm going to go to my window. In the X direction, we had 60 years, so 0 to 60 should work. In the Y direction, I want to take a look at my data. So my smallest one looks like it is the 300.4 in 2010. My biggest one looks like it's 1980 here. So it looks like I'm going to go 250 to 650 as a way to get a little above, a little below, and capture all my data. So 250 is my smallest Y, and 650 a little bigger than my biggest Y. So let's take a look at the graph. I have this one point here, which looks like an outlier. And so I am going to go and see if there's an error in typing my data, because the rest of the points seem to be following a parabola shape. So stat, edit. Oh, yes, there's that outlier. You can see that instead of 30, I typed 3. So go down here, type 30. And that looks like it should fix that. So hit graph. Now my points seem to be kind of related to each other like a parabola shape. So going back to my PowerPoint, it says enter data. We did that. Use your calculator to find a quadratic model for the data. Round values to 2 decimal places. Graph the data and the quadratic model in the same window. Sketch a graph. So in my calculator, I go to stat, over to calculate, and I go down here to number 5. So right after linear is quadratic. So it's this quad. So I hit enter enough times for that to do the calculation. I'm going to round to 2 decimal places everywhere. So negative 0.3017.05, 346.11. So I'm going to type that in my y equals, excuse me, so that I can see this regression beside the data. And I'll hit graph. And I see that it is not a perfect estimate by far, but it is a reasonable approximation. There's some years that are very close and other years that it's an estimate. So it doesn't quite get as high as the data went right there in the 80s and 90s, but all over, it is giving an estimate of the data. So I'm going to make a very rudimentary sketch of what we have done so far. So we have graph. This is years. And since 1950, we went up to 60. We have 0. This was cigarettes and billions. We went up to 650. We started down here though at 250. We did not start at the origin. So we had data points. And we had parabola line. Kind of missed some of those top points. Something of that nature. So ask me to write my equation here. So I'll fill that in from what we got on the calculator. And then it says, explain why quadratic regression was a good choice based on the shape of the data. The data had a clear maximum. Like the vertex. Of a parabola. And with your Google Slides, you're going to be looking for something that either has a clear maximum or a clear minimum, because all the parabola shapes have that maximum or minimum. We have either the U or the N shape. In this case, we have more of the N shape. So we had a concave down shape, and we had both increasing and decreasing data, so it really fit all of the trends. Our next question is to predict when cigarette consumption returns to the same level it was in 1950. So in 1950, cigarette consumption was at 369.8. So my calculator in my Y2, I'm going to put 369.8. Now, I'm going to make my window just a little bit bigger so that I can potentially see this. So for this window, I'm going to put my years into the future. So I'm going to go up to 100 years. We'll see what happens. And for my minimum, I'm going to put 0. So I'm seeing like more of the parabola shape. And I'll hit graph. And so we see just our parabola continuing past the data. And we see this red line coming across, which was the 1950 level. So I do second, trace, intersect to find the answer. Enter for first curve, enter for second curve. Make sure you're close to this answer and not the the left-hand side of your screen. On the left-hand side of your screen, we would get where a number very close to 1950, because that's the first time it was at this level. But we're wanting when it returns to this level, so we want a number that's in the future from 1950. So hit enter, and we get at 55.4. So we'll go back to the context of our problem. So year 55 would be 2005. So during 2005 is when we think this happened. So we did this, we did the intersect, we got 55. And so 1950 plus 55 would give us year 2005. What does your model predict for cigarette consumption in 2015? So to figure out what year I'm looking for, I'll take 2015 and subtract 1950, which is serving as my year 0. And when I do that, I get that I'm looking for year 65. So that's going to be on my calculator. And I'm going to go to my table. So I'm going to go second window, start my table at 0, make it go up by 5, just like my data. And look at my table, and I'm looking for 65, so I do have to do a little scrolling here. And our prediction is 186.86 billion. So 186 billion. We are told here the actual. And the actual is 267 billion, and we're at 186. So does my prediction seem realistic? I would say no. It is off by a lot. Then it asked me, when does my model predict that cigarette consumption will drop to 0? And we have to remember this is a prediction because, at least in my head, reality is that's never going to happen. So in order to see the zeros, I need to change my window. So the 0 to 100 is going to be fine, but I want to see the y value go to 0, so I need to have some negatives here. So I'm going to put negative 100 so that I can see the parabola across the axis and go below the axis. So I'll hit graph. Before I hit graph, I'm going to go back to my y equals, and I'm going to make my y2 be 0 so I can do an intersection here. We could use the 0 root feature as well, but intersection is a little bit easier. So I see my red line and my blue line intersect, so second trace. Here's where I could have done 0 if I had not typed in 0 for my y2. But enter, 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 enter. So 72.7 or 73 years out. So we made everything a little bit bigger here so we could see this. We found this intersection at 73 years. So 1950 plus 73 would be in 2023. Do I think this is realistic? No. Even with vaping taking off, I don't see everyone quitting smoking. So then we're asked a question, and it's a question we often have to consider when we're dealing with parabolas. The parabola fit the data reasonably well, but there's a limitation because parabolas always head either towards positive infinity or negative infinity. And this one with the concave down shape goes to negative infinity, but cigarette consumption doesn't go to negative infinity. So there is a limit to when our model works. And so they asked, what do you think is the limit for our model? Well, from the actual data, from our original graph, and we can look at the graph, it looked like a reasonable model 60 years into the model, which was 2010, this last data point. But when we did 2015, our model was significantly past reality. And so I think the model works just up until 2010, the same as the data. So it fits data, but it does not go beyond. And so my reasoning again is it looked like a good fit through the data points, which were through 2010. And here at number 5, where we did 2015, it was not a good fit at all. So I don't want to continue past my data points. Next, we have then an article. And this is from 2009, so it's very close to the end of our data set where our model stopped working. And in this, it is talking about in 2009 a significant tax increase on cigarettes, which experts in the field were saying would create a decrease in consumption. So I would like you to pause the video and read. We're going to talk about it, but I am not going to read to you. So pause, read the little blurb, and then we'll go back to looking at the problem. All right, so noted in the article, there was this gentleman, Bill Phillips, and he says that consumption has been dropping 3% annually. So based on the 3%, I'm thinking, what function should I use? And the answer there is exponential. And the reasoning is because exponential is for constant percent change. And then we're to write a model. So exponential is an NPAT model. So number of cigarettes, P is the starting amount, and we're supposed to use the 2010 data. So I'll go back to that. 2010, so 300.4, and that's in billions. So 300.4 is my P. For my A, I'm going to have to use A is the idea of 1 minus the percent. minus because it's been dropping. So I'll do 1 minus 0.03, the percent is a decimal. And that will give me 0.97. So my A, 0.97. My T is time. However, my time, my year 0, is actually year 60 in our data set. So we're not starting the exponential function back at 1950 because it does not model the trends with cigarette consumption from 1950. And so I'm going to put this as T minus 60 because I started my model 60 years in. So now it says use this new model to predict 2015. So if we remember from before, 2015 was year 65. So I'm going to have n equals 300.4 times 0.97 to the 65 minus 60. I'm putting in the 65 for the time, and so this would be 300.4 times 0.97 to the 5th when I do the math in the exponent. So I'm going to go to my calculator, do that work. So 300.4 times 0.97 to the 5th. And we get 257.96. So equals 257.96 billion. And it asks, is our new prediction better? And answer for reality was 267 billion. We're off by a lot, but we're a lot better. So is it a better predictor? Yes. It is closer. It's still not exact, but it is closer. It asks us then to graph our model, and we need to take a look at that, and then we need to write a piecewise function. So going to my y equals, clearing out my 0. My new model is 300.4 times 0.97 to the, if you have an older calculator, you're going to need some parentheses around this exponent. If your calculator changes font sizes like mine, you can put all this up in the exponent. So our original graph is blue, our new one is red, and we'll take a look at this combination. And so when we look at our new graph, here, this last data point, both graphs seem to go through that data point. And then the new graph, the red one, shows that the decline in cigarette, it continues to decline, but not as fast. So it is decreasing at a decreasing rate, starting to level off. So looking at our questions, does this ever drop to 0? And the answer is no. Instead, it levels off. And then write a piecewise function. So our piecewise function, we'll write y equals. We put our set brace. We started out this with a quadratic. And so our first is negative 0.30 x squared plus 17.05x plus 346.11. And then our second part of the equation is this exponential model that we made. And so we have 300.4 times 0.97 to the x minus 60. Our first model is for time in years, our x. So let me write this up above. Starts at 0, ends at 60. And our next model then is for the time that is greater than 60. And so we would see that what we would expect as the current trend is this continuing decline, but at a decreasing rate, because we don't expect it to ever go to zero.